It's trigonometric review here. So we're gonna skip this part and go down here. This first question asks us to do the following. Do the following links form a right triangle. And what we want to do is to test. Want to test whether or not that longest side is equivalent to the sum of the squares of the two shorter sides. So let's go back up. My bad. Messed it up. Let's bring this over. Let's bring this over here. Make that 150%. There we go. So here's our test. Test does a squared plus b squared equals c squared. And remember that the longest side is your c. The longest side is your c. Your c, a and b don't matter. We're going to test. Does a squared plus b squared question mark equals c squared? We say 6 squared plus 8 squared question mark 9 squared. 36 plus 64 question mark 81. We get 100. It's not equal to 81. Therefore, this is not a right triangle. Okay. On the next page, we have the same type of problem. We're testing whether or not a right triangle exists, except with the exception. I skipped the page. With the exception that this time they only give us side links. So I'm actually going to go back and undo that. So anyways, so we're testing, does a squared plus b squared equal question mark c squared? Plug our numbers in, 6.4 squared plus 12 squared question mark 12.2 squared. This ends up being 184.96, and it doesn't equal 148.4. All right, so it's not a right triangle. That's how we answer that. All right. In the next part, we're using purely the Pythagorean theorem because we're finding each missing side linked to the nearest 10th. So, the rules: 1, label triangle. 2, evaluate. A squared plus b squared equals c squared. So c is always across from the right angle. A and b don't matter. A squared plus b squared equals c squared. That's our little x right there. We're looking for x. We have 4 squared plus 8 squared equals x squared. 16 plus 64 equals x squared. Get 80 right here equals x squared. Take the square root of both sides. And this value, square root of 80, is equal to 8.94. All right, 15. And this first one, we're doing the same thing. So label C, A, B, which is my x, a squared plus b squared equals c squared. 3.94 3.6 squared plus x squared equals 7.4 squared. 3.6 squared is 12.96 plus x squared. This equals 54.76. Subtract 12.96 on both sides. X squared drops down. (41.80). Take the square root of both sides, and x equals 6.47. Now, for this one, we have for C, we have a squared plus b squared equals c squared. A is x squared, b is 12 squared, this is 13 squared, x squared plus 144 equals 169. Subtract both sides by 144. And x squared equals 25. Take the radical of both sides. X equals 5 inches. Final answer. All right, pretty straightforward stuff. Next part is trig. So I'm actually going to leave that one right there so we can see it. We're going to use sine theta equals O over H. Cosine equals A over H. Tangent theta equals O over A. So we're going to do number 3. So the first thing we do, write these rules down. 1, label O, A, H. So I take that back. 1, circle the angle. 2, label O, A, and H. 3, create the box of knowledge. All right, opposite, hypotenuse, adjacent. Create my box of knowledge. Angle's 39. Opposite is missing. Adjacent is x. Hypotenuse is 7. So this is a cosine. So set up my equation. Cosine of theta equals A over H. Cosine of this angle is 39 degrees. A is x, H is 7. I'm going to multiply to get rid of the x. So solve for x. And just a hint here, if it's x divided by a number, then you multiply the number on both sides. Or number divided by x, we do something called switching. We're going to see that in a minute. But we're going to multiply this number on both sides. This cancels. X equals 7 times cosine of 39 degrees. Put it in my calculator. I get x equals 5.44. All right. So we're going to take those same rules, apply them to the next couple problems. Number 9. Circle the angle. Opposite side, we'll label it hypotenuse and adjacent. Create my box of knowledge. Angle is 40 degrees. Opposite, adjacent, hypotenuse. The opposite is x. Adjacent is missing. Hypotenuse is 19. I come over here, opposite, adjacent, so opposite hypotenuse. So I'm going to say sine theta equals opposite over hypotenuse. Sine of 40 equals x over 19. I'm going to multiply this on both sides. X equals 19 times sine 40. Okay. For the next one, same thing. Circle your angle, label O, A, and H. Set up your box of knowledge, figure out the trig function, and solve. And a tan of 38 degrees equals 20 over x. This is an example of switching. Switch. So I'm going to highlight those. Switch. These two are going to switch. We have x equals 20 over 10, 38 degrees. And remember, press alpha y equals to figure that out. Alpha y equals for that fraction in your calculator. You get 25.60. Over here, circle the angle. Opposite, hypotenuse, adjacent. We have O and H, so we got sine theta equals x over 34. Multiply 34 on both sides. X equals get 12.74. So pretty easy stuff. 17, opposite, hypotenuse, adjacent. We got box of knowledge here. The angle is 63. Opposite is missing. Adjacent is 23. Hypotenuse is x. So we got cosine of 63 equals 23 over x. We're going to switch because we're dividing by x. And x equals 23 over cosine of 63. Get 50.66. Okay. Next we have where we're doing inverses. So when we do inverses, we apply it. So I'm going to apply inverse tan to both sides. So if you want to see that, it's just tan inverse tan A equals tan inverse 2.05. And we say angle A equals, and if we want to see that in our calculators, we can. I'm going to do the second one on here. Right? But for now, I'm just going to go get the answer. 2.05. 64 degrees. For number 2, what number this one? I'll apply the inverse, so tan inverse. So you can see it clearly. We have tangent of y equals tan inverse of 0.6494. This cancels. And y equals, let's go on a calculator here, second mode. So second tan 0.6494. Make sure that's right. 6494. Enter. We get 33 degrees. Okay. Pretty straightforward stuff for inverse trig. So for this next portion, we get a triangle with a diagram. We're going to do the same thing we did before, circle an angle, label sides, do the box of knowledge, except this time we're going to apply the inverse of whatever trig function we're going to use. So circle and angle, the opposite, hypotenuse, adjacent, angle, opposite, adjacent, hypotenuse, angle, we don't know. So we don't know the angle. We don't know the angle, so we're going to go find the angle. The opposite is missing. Adjacent is 8. Hypotenuse is 17. So this is a cosine. So cosine of theta equals 8 over 17. And keep in mind, this angle is missing. So it's going to be cosine of x. Cosine of x here. To get rid, a little bit of space in between. To pull that angle out of the cosine, you apply the inverse of the cosine. This cancels. X equals inverse cosine of 8 over 17. It's 61.9. Okay, moving on. Circle an angle, opposite, hypotenuse, adjacent. Do my box of knowledge, angle, opposite. Got x, 34, 39, and dash. This is going to be tangent of x equals 34 over 39. And apply the inverse, tan inverse, tan inverse. This cancels, x drops out. Last one. Opposite, hypotenuse, adjacent. So I'm making box of knowledge. Opposite, adjacent, hypotenuse, x, dash, 26, and 45. I get the cosine of x equals 26 over 45. Inverse cosine, inverse cosine, this cancels, x comes out, go to my calculator, y equals 26 over 45. I get 54.71 degrees. All right, that's a wrap, guys. For these are pretty simple. We plot the inverse, sine theta equals sine inverse square root of 2 over 2. We should get 45 degrees. We can go check. Second sine alpha y equals second square root of 2 over 2, and it's 45 degrees, which is the answer. All right, that's a wrap for the review for trigonometry and geometry. Have a good day, guys.